Hello friends, welcome to our channel Anand Academy of Education. Today we are going to start a new chapter, Mathematics Basics. Mathematics Basics for examinations like Intermediate, Eamcet, JEE, Mains and Advanced or other state engineering entrance examinations. This chapter is very essential for students in order to crack Eamcet or JEE Mains and Advanced, because without knowing these basics it is difficult to solve the questions in the examination, and that's why it is very essential for us to be very familiar with all these basics that I am going to teach in this chapter. So this is our first lecture and let's get started. We'll first start with the number system. So in the number system, we'll first start with natural numbers. Natural numbers. What are natural numbers? Natural numbers are denoted by the letter N. Letter N. And what are they? What are natural numbers? They are set of numbers, set of positive numbers, set of positive numbers, set of positive numbers. So where do the set of positive numbers start? So they start from 1, 2, 3, 4, 5 and so on. These are all positive numbers. So how can we write the natural number set? So we can write the natural number set as 1, 2, 3, 4, 5, 6 and so on to infinite. So this set is called natural number set. This set is called natural number set and we denote this set as N. We denote this natural number set by the letter N. So the least number in the natural number set is 1. So natural number set starts from the number N. So these are all positive. Natural number set consists of all positive numbers, and it doesn't contain 0. It doesn't contain 0 because 0 is not a positive number. So all the numbers that the natural number set contains is only positive. Whole numbers. So the next number set is whole numbers. Whole numbers is denoted by the letter W. So what is a whole number set? It is a collection of numbers. That start from 0. A collection of numbers that start from 0. Otherwise, we can also say this as a collection of positive numbers, a collection of all positive numbers, and the number 0. So the whole number set can be represented as 0, 1, 2, 3, 4, 5, 6 and so on infinite. So this set is called whole number set. So the whole number set consists of all positive numbers. These are all positive numbers. And the number 0. The whole number set consists of 0 and all the positive numbers. If we can observe, we can write this whole number set as set 0 union natural number set. Set 0 union natural number set. So these positive numbers are nothing but natural numbers. So the whole number set is union of set 0, a set that contains the number 0 and all the natural numbers. So we can say all natural numbers are whole numbers. All natural numbers are whole numbers. But can we say all whole numbers are natural numbers? Can we say all natural numbers are whole numbers? No, we cannot. We cannot say all natural numbers are whole numbers, because in the natural number set we have numbers that are all positive, and we don't have this number 0. We don't have this number 0 in the natural number set, and that's why we cannot say all whole numbers are natural numbers. All whole numbers are natural numbers. This statement is false. This statement is true. And we can also say the natural number set is subset of whole number set, because the whole number set consists of all the natural numbers. So natural numbers set is subset of whole number set. And the third is integers. Integers set is denoted by the number I or Z. It is sometimes denoted by the letter I or sometimes by the letter Z. So what is the integer set? So integer set is a collection of numbers that are negative, or we can say, let's say it like this. A collection of all positive, negative and 0. A collection of all positive numbers, all negative numbers and 0. So we can write this integer set as minus infinite, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 and so on. So the integer set consists of all the numbers that are negative, that are positive and 0. So we can say that the whole number set is subset of integer set. The whole number set is subset of integer set, because if you can observe the integer set, we have all the numbers that start from 0 and that ends at infinite. So this is the whole number set. So we can say the whole number set is subset of integer set, and as we know, the natural number set is subset of whole number set, and it is also the subset of integers. The natural number set is subset of whole numbers, and the whole number set is subset of integers. So we can say all whole numbers are integers. All whole numbers are integers. This is true. But we cannot say all integers all integers are whole numbers. This is false because in the whole number set we don't contain numbers that are negative. The whole number set consists of numbers that are only positive and the number 0. So the statement that all integers are whole numbers is false. The next number set is rational number set. The rational number set is denoted by the letter Q. So what is the rational number set? So we can say the rational number set as all numbers that can be written in the form A by B. So all the numbers that can be written in the form A by B are rational numbers. So the rational number set consists of all integers and the numbers of the form A by B. For example, 3 by 5 is a rational number. 6 by 6 is 1. 6 by 6 is 1. This is a rational number. And of course, this is included in integer number set. And 7 by 8 is a rational number. 10 by 100 is a rational number. Minus 100 by 120 is a rational number. Minus 1000 by 2122 is a rational number, because this all can be written in the form A by B. This all can be written in the form A by B. So what exactly is A by B? If we take 1 by 3, let's take the example of 1 by 3. So 1 by 3 in decimal form can be written as 0.3333 and so on. So we can simply write this as 0.3 bar. So we can say that the number 3 is a recurring decimal. So the 1 by 3 is a recurring decimal. So we can finally say that the number after the decimal is always 3. The number of the decimal is always 3. And so all the recurring decimals are also rational numbers. All the recurring decimals are also rational numbers, because they can be represented in the form A by B. We can represent this 0.333 and so on as 1 by 3. We can represent this as 1 by 3 in the form A by B. And so this is a rational number. But if we take the example of root 2, the value of root 2 is 1.4142 something. So the number after the decimal, it never ends. This never ends. We don't know when it ends. It keeps on increasing, and we don't know what number it comes after the 100th position of decimal number. We need to calculate it. We are not sure about what number it comes, or when the part after this decimal point ends. So root t is not a rational number, because it cannot be represented in the form A by B. It cannot be represented in the form A by B. We can represent 0.333 and so on as 1 by 3, but we cannot represent 1.414 and so on as in the form A by B, because we don't know when this part after the decimal ends. So we need to do this infinite times. We don't know when it ends. And so this root t is not a rational number. So to sum up all the points, so a rational number is a number that can be written in the form A by B. All integers are rational numbers. We can we can represent 1 in the form a by b. So this is 1. 2 as 2 by 1, this is 1. Or minus 2 as minus 2 by 1, this is in the form a by b. So we can represent all the integers in the form a by b, and so all integers are rational numbers. Let me write here. So all integers are rational numbers. All integers are rational numbers, whereas all rational numbers are not integers, because in the integer set we don't contain 7 by 8. We only contain numbers that are either positive, negative, or 0. We don't contain fractions. In the integer set we don't contain fractions, but whereas in the rational number set we contain fractions. So all rational numbers are not integers. All integers are rational numbers, and the integer set is subset of the rational number set. The integer set is subset of the rational number set. Irrational numbers. I have just given you an example in the last slide. Root 2. Root is an irrational number. So this irrational number set is denoted by the symbol q complement. It means the numbers that are not in the rational number set. All the numbers that are not in the rational number set are irrational numbers. So what exactly are these irrational numbers? These are numbers, all numbers that cannot be represented in the form a by b. That cannot represent in the form a by b are irrational numbers. So in the irrational number set would contain numbers like root 2, 1 plus root 2, 1 minus root 2, root 10, root 15, 1 by root 2, or root 2 minus 1, root 99, minus 100 by root 20, and so on. These are all irrational numbers. Because they cannot be represented in the form a by b. So in the last slide we have taken the example of root 2. So the root 2 in decimal form is 1.414. This is up to 3 decimals. This is up to 3 decimal points. But if we go on finding all the decimal points, this decimal part never ends. It keeps on increasing infinite times. We don't know where it ends. It keeps on increasing, and it never ends, to be honest. It never ends. And so this 1.414 cannot be represented in the form a by b. We cannot represent this in fraction form. And so root 2 is not a rational number, and it is a irrational number. So 1 plus root 2, because we cannot represent this root 2 in the fraction form, and so 1 plus root 2 is also an irrational number. Likewise 1 minus root 2, root 10, root 15. Also 1 by root 2. 1 by root 2, you can think, you may get a doubt that this is in the form a by b. We can take 1 as a and root 2 as b. The a by b form doesn't mean that this is in the form a by b, because a by b is a fraction form. A by b in the sense fraction form. So we know that root 2 cannot be represented in the form of a by b. Root 2 cannot be represented in fraction form, and that's why 1 by root 2 is an irrational number. Likewise, root 2 minus 1, root 99 minus 100 by root 2. So all such type of numbers are irrational numbers. And the value of pi, the value pi is also an irrational number. It is also an irrational number. It is also an irrational number. It is also an irrational number. So to sum up the points, all numbers that cannot be represented in the form a by b are called irrational numbers. And now the real number set. The real number set is denoted by the letter R. So what exactly is this real number set? It consists of all integers, rational numbers, and irrational numbers. So we can say integer set is subset of rational numbers, subset of real numbers. Rational number set is denoted by the Q. And also the Q complement is subset of real numbers. So real number set, we can write the real number set as integer set union rational number set union irrational number set. So the real number set is integer set union rational number set union irrational number set. So all these numbers together are called real numbers. So we can write this real number set as minus infinity, minus 3 by 5, minus root 2, minus 1, 0, 1, 2, 3, so on. So it contains all these numbers. So we can say all integers are real numbers, all rational numbers are real numbers, and all irrational numbers are real numbers. So all these number sets are subsets of the parent set. The real number set. So we can say this real number set as the parent set because it consists of all these numbers. So we can say this real number set as the parent set. And now the complex number set. So far we have seen the numbers that we usually observe or that we usually get to see in our books. What are complex numbers? This is the other type of set. This is another type of set that consists of all real numbers and all imaginary numbers as well. So what is this complex number set? So this complex number set is denoted by the letter C. So what is a complex number? Any number. Complex number is any number that can be represented in the form a plus ib. I is iota. So in order to tell what a complex number is, it consists of all the numbers in this universe. All the numbers. So let's see how. So this A is real part. We say this A as a real part and this IB as imaginary part. So let's see how 1 can be represented as a complex number, the integer 1. 1 plus I into 0, I into 0. So we have this real part, and the imaginary part is 0, and the imaginary part is 0. 1 plus 0 is 1, and that's how this one can be represented as a complex number. And let's also see what is an imaginary number. What is an imaginary number? So 1 plus I, this is 1 plus I into 1, 1 plus I into 1. So this is an imaginary number. So let's see another example. We know the value of root 2. 1.414 something. But what is the value of root minus 2? So this value is I square into 2. So we represent this as root 2i. So if we can observe, the value of I square is minus 1. I is root of minus 1. So we only know, so far we are familiar only with the positive roots. But what if we get a negative root? What if we have a negative sign under the root? So like this. So we represent this root of minus 2 as I square into 2. So the value of I square is minus 1. So we can say this as 1 minus root of minus 1 into 1. So this is an imaginary number. So the complex number set consists of all real numbers and all imaginary numbers. All real numbers in this set, it consists of all integers, all fractions, all rational numbers, all irrational numbers, and also all imaginary numbers. So this is the ultimate set. It consists of all numbers in this universe. Doesn't contain there is no number that it doesn't contain. There is no number that the complex number set doesn't contain. So this is the ultimate set, and all the remaining sets are subsets of this complex number set. Another example of 3 plus I into root 2. Let me write it. 3 plus I to I root 2. So this is a complex number. Root 3 is a complex number because here the imaginary part is absent. So this is root 3. This is also a complex number. This is an irrational number and also a complex number. Let's take an example of 3 plus I into 0. The imaginary part is absent. So this is an integer. This is a whole number. This is a natural number and also a complex number. Minus 3. This is an integer. And also a complex number. Likewise, 3i. This is an imaginary number. The real part is absent. 0 plus 3i. We can write this as 0 plus 3i. The imaginary part is absent. So the complex number set is a set that contains all the numbers in this universe. So let's have a small quiz. All whole numbers are natural numbers. Are all whole numbers natural numbers? So what is whole number set? The whole number set starts with 0 and contains all the positive numbers. 0, 1, 2, 3, 4, 5, 6. And what is natural number set? It contains all the positive numbers. So does the whole number set contains all the numbers? Does it contain all the numbers? No. It doesn't contain. The whole number set doesn't contain 0 in the natural number set. The whole number set doesn't contain 0 in the natural number set, and that's why the statement that all whole numbers are natural numbers is false. All integers are rational numbers. So what is the integer set? Minus infinity to plus infinity. So it contains 1, 2, 3, minus 1, minus 1, minus 2. What is rational number set? Any numbers that can be written in the form a by b. A by b can be positive or negative. So all integers are rational numbers is true because the integer set is subset of the rational number set. All rational numbers are irrational numbers. All rational numbers are irrational numbers. Is this true? False, because it doesn't. The rational number set doesn't contain the numbers that cannot be represented in the form a by b. It contains only the numbers that can be represented in the form a by b. Whereas the irrational numbers are numbers that cannot be represented in the form a by b. So these are two different sets. And irrational number set is a complement of rational number set, and that's why this is very false. All irrational numbers are real numbers. This is true because the real number set consists of all integers, all rational numbers, and all irrational numbers. All positive integers are natural numbers. This is true. All positive numbers are natural numbers. The natural number set consists of 1, 2, 3, 4, and so on. So this is a positive number set. These are all positive integers, and that's why this statement is true. Let me add another one. All complex numbers are real numbers. All complex numbers are real numbers. Is this true? This is false because the real number set doesn't contain numbers like 3i. It doesn't contain imaginary numbers. The real number set doesn't contain imaginary numbers, and that's why all complex numbers are real numbers is false. But whereas all real numbers are complex numbers, is true. So this is it for this lecture.